Welcome to the Runtime error. Again, in the linked list series, we will be discussing one more question called as a rotate list from the Leetcode of medium level. So what does the question says that they will be given us a linked list and the value called as a k, and we need to rotate the linked list to its right by k places, right? Just like we did in one more problem, that is to rotate array. I hope so you remember. If you don't remember the way how to rotate the array, I have already made the video. You can have the link in the description box. So say for example, this is the linked list they have given us and the value of k is 2. They have already given us. So what we need to do is we need to rotate this linked list by 2 position to its right. So in first position, the 5 is shifted to its right. So 5 come at start. Now in second position, this 4 has shifted to its right. So 4 comes over here. And this is my final result after rotating the linked list by 2 position. I hope so you got the meaning of the question. Now the question comes, how can we approach this problem? Is there any way to solve this problem? Since we did it in array, is there any similar fashion that we can do in list as well? Let's see. So the example which we have given is as 1, 2, 3, 4 and 5. Okay, the first solution that comes in our mind is brute force solution, right? Brute force solution. So what it could be? Can I say I can copy all the elements of my list inside my array and I can rotate my array. Once I rotate, I can simply push back inside my list, right? How can you rotate the array? I have already made the video, you can check out it. We have discussed the 3 ways to rotate array. 3 ways. So the first thing that comes in our mind is simply what we can do is, so we got the linked list is of length 5. So what I will do is I will simply create an array of 5 as 1, 2, 3, 4 and 5. And what I will do is I will simply rotate the array. I will not be explaining in detail how to rotate the array in this video because it will simply increase the size of my video. So rather than, it's better to keep it simple and small. So we will discuss a brute force solution. To know about this brute force solution, watch my video that rotate array. Now let's move on to the optimal solution. Now the second solution we will be calling as optimal solution. So we have given a list that is of as 1, 2, 3 and 4. Say for example, add 10, 50, 60 and 30. So it contains as 50, 60, 30 and it is null since it is my last node, and I have also given as a head which is pointing to my first node. Now the value of k is equals to 2. We need to rotate this list to its right by 2 position, right? By k equals to 2 position. How can you do it? But the point is, before rotating this list, let's discuss one of the most important thing in this problem, that is the value of k. Say for example, I have the list of size 3. And I want to rotate it by 2 position. Can I say it would be as 2, 3 and 1? Okay. Now say for example my value of k equals to 1. So it would be as 3, 1 and 2. Right, this is my first, this is my second. Now say for example my value of k is equal to 3. Can I say for value of k equals to 3, my list would remain as it is. Now say for example k is equals to 0. Do I need to rotate my list? No, because I don't need to rotate since my value of k is 0. Now in this we have discussed for k equals to 1, we rotated this way, which means the 3 came just one step ahead, that is 3, 1 and 2. Now let's check for value of 4. So for value of 4 again, it would be 3, 1 and 2. Is it matching to something? Is it matching to this one? Is it matching to something this one? So can I say how many cases we are getting over here? If my k equals to 0, don't rotate, simply return, right? If my value of k equals to n, where n is the length of the linked list, again don't rotate. Again, if my value of k is greater than n, then what we need to do is, will you rotate those many times? No. So what we will do is, we'll try to reduce the size of k. How can we reduce? We got k equals to k modulo n. So this is the formula we will be using to reduce the size of k. I hope so you got these three cases, right? If my value of k equals to 0, I don't need to rotate. If my value of k equals to n, again I don't need to rotate, because anyhow my answer is going to be the same. And if my value of k is greater than my n, that is my size of a linked list, I simply reduce the value of k so that I can avoid the extra rotation. Now let's check how we can do this. So let's copy this example. We will copy this example, right? Okay, how we can do this? Now first thing what I will do is, I don't know how many nodes are there in the list. So the first and the foremost thing what I will do is, I will calculate the size of my list, right? How can we calculate the size of list? I have told you the traverser technique. So what I will simply do is, while traversing the list, I will simply keep the counter so that we can come across the total number of nodes. So what I will do is, I'm keeping the temporary pointer, since I told you not to make changes in our original data. So simply I'm assigning it to its head. So while my temp of next is not equals to null, which means till here I need to count how many nodes I have. So simply can I say counts plus plus I will do, and I will simply take my pointer one step ahead. So this will be the total number of, my total number of nodes. I will write over here total nodes. Now the point is, why do we need a total nodes? We will discuss it further. So initially my count will be equals to 0, right? So this we calculated the total number of nodes. Now in this example we got the k equals to 2, which means I need to rotate these two value, right? I need to rotate these two value. Now can I say I need to rotate the last two values? Do I need to change anything in my first values? Absolutely no. So what I will do is, instead of rotating whole list, I will try to rotate only my last k values. I'm talking last k values. Since the value of k is 2, I will rotate only 2 elements, 2 nodes. So what can I do is, how many elements I need to go further in order to rotate last 2 nodes? I repeat, how many nodes I need to go further in order to rotate last k nodes? Can I say n minus k, right? Initially in this, what is the value of n? Is 4, and what is the value of k is 2, which means I need to go 2 nodes ahead in order to rotate last 2 nodes. So this is first and this is second. So I will come over here. Now what I need to do is, I need to rotate these list. So can I break this? So that I can make these two lists separate, because anyhow I need to bring these two nodes at my front position. So do I need to keep this junction? No, I can simply delete it and bring these whole 2 nodes at my start. So how can we do this? How can we come over here? Can I say I need one more pointer? We can come up to here. But the point is, how we will come to know that where I need to stop? That way. So what I will do is, I will keep one extra variable, say for example cnt, right? How many nodes we need to go? So we got a total number of nodes as n minus k, right? So what will be the value over here? This is 2. Now we'll keep one extra temporary variable, say for example x, which is at 1. Initially it's 1, right? So what I will do is, while my x is not equals to cnt, keep going, that is temp equal to temp of next, and at the same time I'm increasing the value of x as well. Now point is, where is my temp is pointing? As usual, temp will be pointing at head. So can I say over here temp equals to head? Yes, which means from this position I am moving till this position. So what will happen? Let's check. So my temp is at head, that is over here. My value of n is 4 and my value of k is 2. So what will be the value of cnt? It will be 2. initially my x is equals to 1. So my temp is at first node. I will check, is x equals to cnt? No. So what will happen? The value of x will be included as 1, 2, and the temp will come one step ahead, that is over here, and this will be deleted. Now again we will come back over here and check, is my x is not equal to 70? No, this condition get false since both are equal, so we come out of it. I hope so how we came up to this node. Now what I need to do is, we need to delete this junction because I need to bring these whole two nodes at my front position. So can I say simply can I do as temp of next equals to null, so that here it will contain as a null, and this junction has been broken. So we got a two different lists. We separated two lists, but the point is how can we access this list, because we don't have any particular node in order to know about this list. For this list we got head, right? But for this list where it is head, is there any kind of pointer we will able to access this list? No. This is the reason why before breaking this node, before breaking this junction, we need to keep one extra pointer at this position so that we can able to access this list. So what I will do is, I will declare one extra pointer, say for example called as front, and I will assign it as temp of next, which means it was having a 60 and it was assigning to this. So temp of next is equal to 60. So node, this front will be containing a 60, which means can I say my front is pointing at this location. Now can I say, can I break this node? Can I break this junction? Absolutely yes. So here I will make it as null. Now what I will do is, I will simply do as temp of next equals to null. Now it is valid one because I have the access to this node with the help of head. I have the access to this linked list with the help of front. Now what I need to do is, I need to bring these two at front, because what is my final answer? My final answer is, let's check, first 4 will come, then 3 will come, then can I say it should be 3, then comes as 4, then comes as 1, then comes as 2, right? Yes. But the point is my head is pointing at this position. These two lists have been separated. Now what I need to do is, in head I need the address of this list, right? In head I need the address of this node, and this node should point to this node. So it would become 3, 4, 1 and 2, right? Head should point to this node, so that this is my starting point. As you can see that 3 is my starting point, and now 4 is pointing to my first node, right? Which means this 4 is pointing to this node. That is, here it should contain the address of this node. How can we do it? Let's copy this example once again. So I copied this, pasted this. Okay, now how can we keep the address of these 3 in my head? Now what can I do is, I need to traverse till go back. Why do we need to traverse my second list? Because I need to store the address of this node or my last node in my first node. Am I right? I need to store the address of my first node in my last node. Now the point is, can I move my front pointer? No, because the point is, as I told you earlier, if you move the head pointer, you will totally lose the access to the front point of my list. Similar fashion, if you try to move this front node, you will lose the access to the first node of my second list. But the point is, do we need this front pointer? Let's check. So what I will do is, I need to store here the address is 10, right? So that this can point to this. I hope so you got me. So what I will do is, I will take my front ahead. So till my front of next is not null, move ahead. So front is equal to front of next. Okay, my front is at this. Is front of next is null? No, it contains 30, so my front will come over here. My front will come over here. Now initially it was null. Let me make changes. Now front of next is equal to not null, but it is null, so this condition get false. Now what I will do is I will simply store the address of my head. So it will be front of next equals to head. Now this 4 contains as 10. So what will be my final answer? Okay, now what we did is here, now the front of next, what we did is front of next equals to head. So head contains 10, so it will contain as 10, right? My head is pointing to 1, so what it would look like, see, I have got 3 which contains 30, it is pointing to my 4 which got 10, and it is pointing to as 1 was 52, right? And my head is pointing over here, but the point is I need to point this head at my first position of my list. How can I point it? Because I have totally lost the control over this node since I moved my front pointer ahead, right? I hope so you got me. This is the reason why I told you not to move the front pointer. Reason why, though we rotated the list, but my front is pointing to this node, but I wanted to point it at this node, because if we try to check our answer is 3 4 1 2, but if we return head, my answer will be 1 2. We have totally lost this. This is the reason why what I will suggest you, instead of moving this front pointer, keep one temporary pointer once again, say for example called as a second. Now what I will do is I will move this second till the end, so I will make changes in this code. So instead of front, what I will do is second. Here it will come as second. So my second is pointing over, second of next is not null, condition gets true, so it will come at over here, right? So this will get vanished. Now again I will check, here it is null, second of next is not null, but it is null, so condition get false, so we come here. Now what I am doing is second of next equals to head. So what is the value in head? 10. So here it will come as 10. Now what I need to do is I need to assign the head to this position, so that this would become my starting point of my linked list. Now simply can I say head equals to front, right? Head equals to front, which means head is pointing at this position, so my list become 3 4 1 and 2, and this is the answer which we were looking for. I hope so you got me why we use extra variable called as a slow, so that we can have a total control over my first node in order to assign its value to the head, right? So I hope you clearly understood the way I taught you. Now let's check the code more in detail. Okay, so this is the code which we have wrote on the Leetcode. So the first function shows that to find the length of the list, as it is named that get length. So what we did is we simply passed the head of the list, and what does this is that if my linked list is empty, simply the length of the linked list is 0, so it simply returns 0. Now I have initialized the counter which is equals to 0 now, and what I did is since my head is present at my first node, I am simply traversing my list. So now head is not null, so condition gets true, count become 1, and now head is moved to the next position. Now again head is not null, condition gets true, so count becomes 2, and head moved to the next position. Now again head is not null, condition gets true, it gets 3 and it comes over here. Still it is not null, condition gets true, count becomes 4 and simply move over here. Now again my count is still not null, so it gets true and it becomes 5, and finally my head turns out to be null, and this condition gets false and we come out of the loop. So this function simply gives you the answer 5, which simply tells us a number of nodes inside my list. Now we will check this function. So what does this function tells us? So this function is basically used to rotate our list. So what we did over here is, again my list is empty, or if it has a single node, say for example it has single node, do I need to rotate a list? No. So I simply return the head. Now here we calculated the length of the list. So my basically the length is equals to 5 of a given example. Now as I told you in the previous part of explanation, if my k is greater than or equal to my length, what I need to do is I simply need to reduce its size by modulo. And if it is k equals to 0, I don't need to rotate it. So I simply return the head. But initially my k value is 2, which is less than 5. Right? So now what I did is I simply took one pointer which is pointing to the head. Let's call temp. And what is the value of k it becomes? So k becomes length minus k, that is 5 minus 2 minus 1 equals to, it becomes 2. Why I took this minus 1? Because I'm starting from 0th index. While explaining you, I told you from first index, but here I'm telling you from the 0th index. So this is the reason why I did one extra minus 1. So my temp is present at my first node. Then I come over here, k equals to 2, right? Is my k is equals to 0? No. Condition gets true. So my temp comes over here and it gets reduced to 1. Now again, is it equals to 0? No. So this condition gets true and comes inside. So temps get over here. And finally my k becomes 0. So we will come out of this while loop. Now what we did is we basically use a front node. As I told that we need to have some extra pointer so that we can keep the track of my second list. So my front is pointing to the temp of next. So temp of next is 40. So front will simply contains 40, that is at this position. Now what we did is temp of next equals to null. So we simply deleted this. So here it contains a null, which means it simply broken the path of this. Now we got a two different lists, right? We can see that is this and this. Now temp equals to front. Now again what I did is I simply brought temp over here once again, right? Where at the front position, and simply I traverse till my last node. So this will get vanished from this side. Now what I did is temp of next equals to head, which means at this position I want to insert the address of this node because my list is starting from 4, 5, 1 and 2. So what I did is basically, so temp of next is putting my head. So value of head is 10. So it will be pointing to this node. And at final what I did here is head equals to front. What does it mean is initially head is pointing to my first node, but it should point to the 4 because the starting point of my list is from this 4. So it should go from this way, right? So this is the reason why head equals to front, and which is the front is pointing to this location. So what does head contains is, so the head contains as 40. So head would be pointing to this, and finally my list becomes as 4, 5, 1, 2 and 3, and this was the answer which we were looking for. I hope you understood the explanation part and the coding part as well. If you really like the video, do subscribe the channel. Until then, have a happy coding.